All right, this video is going to start with grading 11.3. It's out of 55 points. Please make sure you're grading in red. Number 1 is combustion. For type of substance and work, remember this is not worth a specific amount of points, but you definitely want to be writing things here to help you predict products correctly. You should notice that it's a hydrocarbon with oxygen, so that's going to give you products of CO2 and H2O. You just have to know that. Because this is an even number of carbons, you're going to double the hydrocarbon. So then you should have 2 C4H10 plus 13 O2 arrow, 8 CO2 plus 10 H2O, and those are all in lowest terms. Number 2, you should have synthesis. Metal plus nonmetal gives you an ionic compound. It would definitely help to write the ions, reduce crisscross. So you have 2 Li plus Cl2 gives you 2 LiCl. For 3, you know that that's double replacement because it's 2 ionic compounds. It would definitely help to put the ions. So you should have Na plus, SO4 2 minus here, Ba plus, Ba2 plus, Br1 minus. So then you switch the positive ions. So you have Ba2 plus here with SO4 2 minus, Na1 plus, and Br1 minus. So you get Na2SO4 plus BaBr2. Half point for them each being 1, and then BaSO4 plus 2 NaBr. For 4, that's decomposition of an ionic compound. It's going to separate into metal plus nonmetal. Remember, anytime you have a nonmetal completely by itself, you should ask yourself, is it a diatomic? In this case, it is. So you should have CaCl2 arrow, Ca plus Cl2. All coefficients are 1 and in lowest terms. 5, you should have single replacement. Why? Because it's an element plus an ionic compound. Remember, the question you should be asking yourself is Al higher than Fe? I checked the activity series and it is. So Al3 plus here, Fe2 plus, NO3 1 minus. So then here, when they switch places, you end up with Fe2 plus, but you want to write it as an element, so it's just Fe. And then here you have Al3 plus and NO3 1 minus. That's going to give you Al, NO3 3. To balance, you need a 2 in front of this Al, 3 in front of Fe, NO3 2, arrow 3 Fe plus 2 Al, NO3 3. For 6, this is single replacement, metal plus an ionic compound. Remember, these are already happy. So in order for this metal to replace the metal in KCl, we need to ask ourselves the question, is Ag higher, more reactive than K? And the answer is no. So it's a no reaction, but to remember to get full credit, you have to put the reactants Ag plus KCl, and that gives you Nr, and the coefficients are 1 because it can't balance anyways. 7 is combustion of a hydrocarbon. Once again, products are always CO2 and H2O. To balance, you don't want to double. Coefficients are 1, 11 on the left side. On the right, products are always CO2 and H2O. Coefficients here are 7 and 8. For 8, you have decomposition. An ionic compound is always going to separate into metal plus nonmetal for decomposition. You ask yourself every time there's a nonmetal over here, is it a diatomic? And if it is, you put a 2 after it. So you have 2 Al2O3, arrow 4 Al plus 3 O2. Last one here, decomposition. This is a molecule, though, so it's going to separate into nonmetal and nonmetal. And remember, you got to ask yourself, are these diatomics? In this case, they are. N2H2, 2NH3, arrow N2 plus 3H2. So now, once again, make sure that you have your score out of 55 points and keep this for the next time that I see you. For the notes now, we are on page 9. In the middle of the page, you want to make sure that you have your periodic table and something to write with in a different color. And we're going to get started with solubility notes. All right, when it comes to reactions, many reactions that involve aqueous substances, that means that they're dissolved in water. So a solute is a substance that is dissolved. So in your first blank there, you should have the word dissolved. And a solvent is the most plentiful substance in the solution. Usually, right, things are dissolved in water, and we term that aqueous. So An aqueous solution is a solution with water as a solvent. I would make sure that when I ask you in the pre-lab, what does aqueous mean? You definitely put a solution with water as a solvent. I will not accept just AQ because that just represents what those letters are. You should tell me a solution with water as a solvent. So when ionic substances, right, and molecular acids dissolve in water, they dissociate into individual ions and are more accurately expressed as products of the following equation. So I can see right in this image that I have a bunch of H pluses and Cl minuses floating around. The problem with chemistry, though, is that when I have dissolved ions, it doesn't look like this. It just looks like water. And so it's important that we can represent what they actually look like. Same thing here. When I add sodium chloride to water, it dissolves and it dissociates. So it doesn't stay as a solid, and instead it stays as Na plus and Cl minus. Remember when we looked at electrolytes in chapter 7 that ionic compounds can conduct electricity. The reason why is because those ions are separating, and when they separate, you have positive and negative ends, and so you have a complete circuit and the electrons can flow. So when substances are put in water and dissolved, calling them an aqueous is easy, but it's not an accurate depiction of how the particles exist. So let's look at what NaOH actually looks like. More towards the bottom of page 9. NaOH aqueous can be better represented, right, as separating into the ions. So what are the ions that make up Na plus and OH minus? I have my periodic table and my polyatomic ion list, right? Na is Na1 plus. So I have Na1 plus. And I have OH, and I know that that's hydroxide right here. And that's 1 minus. And it's best to represent these as dissolved ions, so that's going to be aqueous and aqueous. And then I make sure that they are balanced, right? So 1 Na, 1 Na, 1 hydroxide, 1 hydroxide. So technically, these all have a coefficient of 1. The next one, though, MgCl2. First of all, there's no such thing as a diatomic ion. And so many students want to tell me that there is. But there's no such thing as this. All right? So we have to look up the ions that make up this ionic compound. So I know that Mg is 2 plus. So I have Mg 2 plus, and that's aqueous, plus Cl. So here's Cl, right? It has a charge of 1 minus. Cl1 minus, and that's aqueous also. But how do I count for this 2 here? I have to double it here. So what does that really mean? It means that if I put this right into a beaker of water, right, I'm going to have Na plus, a bunch of these, but for the sake of just understanding it, I'm going to have Na1 plus and OH minus free floating. But what if I do that same thing for the magnesium chloride, right? I'm going to have Mg2 plus separating with 2 Cl1 minuses. That's what that means, okay? So now, how do I know if the compound is soluble, right? So like if I put NaOH and I put MgCl2 in water, they're going to separate into ions. But that's not the case for everything, right? So what I have to do, right, when I put a compound in water, it may dissolve, it may not. So how will I know? I'm going to use the solubility table. The solubility table is on the back of your periodic table. Specifically, right, you're looking at this one here on the right side of the back. This page, though, or this table, is also in your homework packet after 11.3, and it looks like this. I would encourage you, though, to use this one because this is the one that you're going to be using on the test. So you got to know how to use it, which is the same one, but at least you know where it is. So now there's 3 notations, right, that we are going to figure out. 2 come from here. If it's soluble, all right, if I put one of these compounds and it says soluble, right, soluble means that it is going to be aqueous and it dissolves. What if it's insoluble? Does not dissolve in water. And so what I need to know is that if it doesn't dissolve in water, right, it's going to stay as a solid. So stays as a solid. And if it forms H2O, right, that's H plus and OH minus, right, coming together, they're going to form H2O, which is a liquid. So I'm going to put L for liquid. All right. So now we're going to practice on page 10. This table here is going to be on the test. And you have to write it just like this. I'm going to give you the substance. You have to tell me the state of matter and then the dissociation reaction. So I look up AgCl. AgCl comes from chloride. Chlorides are soluble, which means most of them like to dissolve in water. But there's exceptions. Ag1+, Hg22+, and Pb2+. Well, that means that Ag1+ will not dissolve. So AgCl is a solid, and that's why I put a solid here. So now, if it is a solid, right, it's not going to separate into ions, and so I have to rewrite that it's AgCl as a solid, will not dissociate, so it's a no reaction. Now let's look at PbNO3 too. I need to know what state of matter. So I look here. NO3 is nitrate. So I look here. Nitrates are soluble, no exceptions. Soluble means that it all dissolves, so it's aqueous. So then it's going to be AQ here. So then I have PbNO3, 2 aqueous. Now this separates into the ions, right? So I look for Pb. Pb can be over here 2+ or 4+. But in this case, it's with nitrate. So I look at my ion sheet. Nitrate is here. That's 1-. So Pb and NO3, 1-. Because NO3 is 1- and there's 2 of them, Pb has to be 2+. First thing is make sure your ions are correct. Then I have AQ, AQ. And then I have to check if it's balanced. Do you see how there's a 2 here? What's going to happen is I have to account for that 2 by putting a 2 there. All right. Now, if you feel like this makes sense to you, I would definitely go ahead and try the next 2. If not, we can do them together. So if you don't want to try on your own, you can just go ahead and continue on the video. So I'm going to look on for Ki. Ki is iodide. So here, K iodide comes from I-. It's soluble. So all of them like to be aqueous except for these. Well, K is not one of these. So Ki is aqueous. So I write Ki, aqueous, separates into the ions. K, right, is here, 1+. And I, right, is going to be 1-. So these are also aqueous. The next one, Al2CO3, 3. So I'm going to look at CO3. CO3 is actually a polyatomic ion. And so we're going to look at here, it's carbonate, right? But I can definitely look on my solubility chart And so I look for carbonates. They're insoluble. Insoluble means it likes to stay as a solid, right? Unless it's one of these, group 1A or NH4+. So most likely it's going to be a solid, except for group 1A. So group 1A is this one here. So is Al in this family? No. And then, or it can be if it's NH4+, which it isn't. So it's going to stay insoluble, so it's going to be a solid. Remember though, I have to rewrite it over here. And it's no reaction. Okay? So now what is your homework? Your homework is to do 11-4, which is this one. And this has to be turned in before 3:15 today, the whole thing. And then your other homework, we talked about this in class, but it's the pre-lab for the combustion lab. So I want us to look at that. Don't forget the purpose. Students always seem to forget. Floor, we talked about in the notes at the beginning. Make sure you do that. And then here, reason for prediction, you can say that it's going to stay constant, right? You can say too much, too little, right? Things like that. And then you stop here. This will be collected. So the purpose and 1 through 10 will be collected in class the next time I see you, and you also need to be dressed for lab.